In this video, we are going to look at how to simplify a square root expression. So you'll notice in the table, I have a list of some of our common perfect squares. These are numbers that you should be really familiar with, and when you see these numbers, you should know right away that they are perfect squares, and you should know what their perfect square or what the square root of each perfect square is. So for instance, in the first example here, you'll see we have the square root of a blank spot, basically. So the square root of some unknown number is equal to 1. So our goal is to figure out what number should go underneath or inside that square root sign. So I have the square root of some unknown number, and that should equal 1. Now, the number I'm looking for has a vocabulary word. It's called the radicand. So the radicand is the number that you're taking the square root of, and then you're trying to find its square root. So I want to know what number I would put in the spot of the radicand. Well, if I take the square root of 1, my answer is 1. So the radicand would be the number 1. In the next example, I need to take the square root of 4 in order to produce an answer of 2. In the next example, I need to take the square root of 9 in order to produce the answer of 3. And I need to take the square root of 16 in order to produce the answer of 4. So you can see that we're looking for the number that fills the spot of the radicand. So in the next row, I have the square root of 25 is the radicand, and that would equal 5. Then the square root of 36 equals 6. The square root of 49 equals 7. And the square root of 64 equals 8. Let's do the last row. The square root of 81 equals 9. The square root of 100 equals 10. The square root of 121 equals 11. And the square root of 144 equals 12. And then you can see I have one more complete statement. The square root of 169 equals 13. So like I said, these are some common numbers, and you need to make sure that when you see these numbers that you're aware that they are perfect squares and you know what the square root is. So let's go over that vocabulary again. So the number 169 is called the radicand. And when the radicand is a perfect square, like we have in this example, 169 is a perfect square. When the radicand is a perfect square, the answer or the square root, so the number 13 in this case, the square root is a whole number. So that's what it means to be a perfect square. It means that the square root is a whole number. So if the square root of a number is a whole number, then the number you started with was a perfect square. Okay, but now what happens if our radicand is not a perfect square? For instance, in example 1, you can see that we're trying to take the square root of 40. Well, 40 is not a perfect square because if I take the square root of 40, I don't get a whole number. Like if I try to take the square root 40 on my calculator, I will get a decimal. So that's where we use this property. So the property in the box says that I have the square root of a times b. It's equivalent to the square root of a times the square root of b. So the square root of the product of two numbers is equal to the product of their separate square roots. So let's see that in action. So let's look at the square root of 40. So my goal is to find a factor of 40. Since 40 is not a perfect square, I want to find a factor of the number 40 that is a perfect square, and that will help me simplify my square root. So if I think about factors of 40, I know that 40 is able to be factored into the number 4 times 10. Now, I could also use 8 times 5 or 20 times 2, but remember, my goal is to find one factor that is a perfect square, and the number 4 is a perfect square. So that's why I'm going to choose to rewrite the number 40 as 4 times 10 instead of 8 times 5 or 20 times 2. Now I can see that property in action. The square root of 4 times 10 is the same as the square root of 4 multiplied by the square root of 10. Now I have factored my square root expression into one square root that can be simplified to a whole number, and then one that cannot be simplified any further. So the square root of 4, as we know, is 2. But since I cannot simplify the square root of 10 any further, it just becomes 2 times the square root of 10. And that's my final simplified answer. Now, you might be thinking, well, what about the number 10? I can factor 10 as 2 times 5. And yeah, you're right, you can. But 2 is not a perfect square and 5 is not a perfect square. So that doesn't get me any farther. I can't simplify that any further. So I'm looking for factors of the original radicand that are perfect squares. And there are no more perfect square factors of the number 10. Okay, let's take a look at example 2. I want to find a perfect square factor of the number 32. So if I look up in my table, I'm going to use the fact that the square root of 16 is equal to 4. So when I factor the number 32, I'm going to rewrite it as 16 times 2. So 16 is a perfect square. So the square root of 16 multiplied by the square root of 2 simplifies to 4 because the square root of 16 is the whole number 4. And then I multiply that by the square root of 2. And now I have a fully simplified square root expression. So 4 times the square root of 2. All right, let's look at one more example, example 3. So I need to find a number that is a factor of 80 that is also a perfect square. Now I'm going to show you this 2 different options. And hopefully after the first option, you kind of catch on and see how we could have done it a little more efficiently. But I want to show you both ways because chances are you'll probably find yourself doing both ways and then hopefully you'll gravitate toward the method that's a little more efficient. So for the square root of 80, right off the bat, you might recognize, well, okay, 80 is divisible by 4 and 4 is a perfect square. So let's rewrite it as the square root of 4 times 20. So that gives me 2 times the square root of 20. So notice right away, I saw that the square root of 4 is the whole number 2, and then 20 is not a perfect square. Now, you might think we're done. Okay, 20 is not a perfect square, but I can continue to factor the number 20 into 4 times 5, and then there's another perfect square of 4. So now this becomes the 2 that I originally had times another 2, because the square root of 4 is 2, and then the 5 has to stay under the square root sign. Now, to simplify, you would multiply the 2 factors of 2 together for a final answer up here as 4 times the square root of 5. Now, on the next slide, if you keep watching the video, keep watching the video, you'll see a more efficient way to simplify the square root of 80. So let's go on to a new slide and let's look at the square root of 80 one more time. So I have the square root of 80. Now I could have simplified this much more efficiently by finding the largest perfect square that is a factor of 80. So if you realize that 80 is the product of 16 times 5, then you would have noticed, well, hey, look at that. 16 is my perfect square. So if I think of this as the square root of 16 times the square root of 5, then I can simplify the square root of 16 simply as 4, and then you'll see much more efficiently and much more quickly I arrive at my answer of 4 times the square root of 5. Okay, now is where I would like you to pause your video, and there is a you try it problem on the worksheet, or a your turn problem on the worksheet, where you're going to try to simplify the square root of 28. So pause the video, simplify the square root of 28, and then restart the video and verify that you did arrive at the correct result. Okay, so now you should have simplified the square root of 28, and you paused your video, and now you're going to see if you have the correct answer. So the square root of 28, we want to find a perfect square factor. That would be the number 4, and we're going to multiply that by 7, because 4 times 7 is 28. So this tells us the square root of 28 is the product of radical 4 times radical 7. I can also say radical instead of square root. And then I know that the square root of 4 is 2. So I have a 2 that no longer is underneath the square root sign, but then the 7 has to stay as the radicand. So my simplified answer is 2 radical 7, or 2 times the square root of 7.